Okay, in this presentation we are going to look at contingency tables. Okay, so we're going to use these as a sort of method and approach to learn about probability, just to sort of convert raw data into tables and sort of see the various scenarios and what depends on what and what is conditional on what. Now, correctly, this actually is not a contingency table. It is a probability table. Essentially, the contingency table will contain raw frequencies, whereas this has percentages, proportions. And the reason for that is really just to speed things up. This exercise concerns departing flights from an airport that are destined for either inside Europe or outside Europe and whether or not they depart on time. So essentially what we have to do is consider the following questions on the next page based on this probability table. So what we have here is we have flights that are either destined towards somewhere inside Europe or outside Europe. So 62.94% of flights at this airport are destined inside Europe. Okay, and the complement to that is 37.06. They are heading outside Europe. Okay, likewise, we have 78.82% of flights departing on time and 21.18% of flights departing late. And again, the row totals and column totals, which are the marginal totals, in both cases add up to 100%. Okay, so what we have there is joint probabilities or joint frequencies, proportions actually. So here are our exercises for a randomly chosen flight departing from this airport. What is the probability that it departs on time, that it departs with a delay and is a flight outside Europe, and then the probability of departing on time and is a flight outside Europe. Okay, departing on time given that you know it is a flight within Europe, and is a flight within Europe given that you know that it departs on time. So the last two there are actually related to conditional probability. So they're looking at one case only. Okay, so we're going to use the conditional probability rule in those cases. For exercise A, B, and C, really it's straightforward enough. So just what we have to do is remind ourselves about this table here. Okay, so in the first case, the probability that a flight departs on time is essentially the total probability of the on-time departures. So the 48.82% go inside Europe, 30% go outside Europe. Altogether, that is 78.82. Essentially, we're reading that total value on the last column on the right-hand side, up at the top, 78.8. That corresponds to the probability of leaving on time. So the probability that a flight departs with a delay and is a flight outside Europe. So it's late and it's going outside Europe. That is 7.06%. Okay. So that's just looking up the table. It's a straightforward reading of a value from the table. These are sort of straightforward enough, really. Okay, but we're going to get a little bit more complicated. Here we use the union of two events, the formula for the union of two events. So this is where we start to get used to some of the notation used in the introduction to probability. So the probability that a flight departs on time and is a flight outside Europe. Now, just reread that question. Departs on time or is a flight outside Europe. So there's two things we're asked here. So it either departs on time or it's a flight outside Europe. Now the flights outside Europe can include the ones that are late. Okay, so it's or. That or is a very important word there. So essentially, what we use is the formula for the union of two events. So the probability of A union B is equal to the probability A plus the probability of B minus the probability of A intersection B. So we have the union symbol there and the intersection symbol. So really you should get to know them. Here A is the event that a flight departs on time, and B the event that it is a flight outside Europe. I changed the wording there without fully changing it all. So the probability of A union B is the probability of on time or outside Europe. And this is equal to the flights that are on time, the probability of the flight being on time, plus the probability of being outside Europe, minus the probability of on time and outside Europe. Okay? Now, why do we subtract that bit at the end. Why are we doing that? Probability on time and outside Europe. The reason is it's to stop it getting counted twice, because we count that scenario once when we're talking about the probability of on time, and a second time when we're looking at the probability of outside Europe. So we essentially just have to reconcile things and subtract it once just to stop it getting double counted. So let's look at the numbers here on the next page. Probability on time is 78.82%. Probability of outside Europe is 37.06%. And the probability of on time and outside Europe is 30%. So essentially what we have there is the probability of on time or outside Europe is 0.782882 plus 0.3076 minus 0.300, and that works out to be 0.8588, 85% essentially. Okay. Now, what is the probability that the flight departs on time given that it is a flight within Europe? So now we're looking at conditional probability here. So how do we verbalize that? So using conditional probability, we have the probability of on time given Europe, okay, inside Europe essentially. So that vertical bar suggests given. Okay, so what we're going to do there is use the conditional probability rule. So here, how we would express it in this instance is the probability on time and Europe divided by the probability of Europe. So from the tables, the probability on time and Europe is 48.82%, and the probability of the flight departing towards Europe, somewhere inside Europe, is 62.94%. So the probability of on time given Europe is 48.82% divided by 62.94%, or in other words, 0.4882 divided by 0.6294, which is approximately 0.7758. And that makes sense, really, if you think about it, that the ratio is probably 3 to 1 if you look at the table, so it should be around 75%. Okay, so again, we're just looking at the flights that are destined towards Europe. Okay, and something similar here, the probability that a flight is within Europe given that it departs on time. So something very similar here. It's actually just using the opposite sort of situation, or just reversing things from the last exercise. So that is the probability of Europe given that it's on time, and that is equal to the probability of on time and Europe divided by the probability on time. This is almost the same, but a completely different. It's similar, but completely different is what I'm trying to say from the last exercise. Just remember, the phrasing here is completely different. We're asked two completely different questions here in exercise D and exercise E. And this is something to pay attention to. Just read these questions very carefully. So here it's quite explicit, given that it departs on time, what is the event conditional on. Okay. So what should be under the bracket, under the fraction. Anyway, probability of on time and Europe divided by the probability of on time. So that again is 48.82%. The probability of an on-time flight is 78.82%. So we divide 48.82 by 78.82. That is 0.4882 divided by 0.7882, which is approximately 61%, 0.6195. Okay, so that sums it all up there. So that is the 5 questions that we have answered with regard to this contingency table, this probability table. Okay, so conditional probabilities is probably one of the key things there, and just actually getting used to conditional probabilities, and also the notation, the intersection symbol and the union symbol. Okay,